Howdy, folks. I'm Lich, and this is my first game devlog. Now, I've been working on a game for just shy of the past 3 months, and I wanted to make devlogs for a little bit now, and I figured that I had a pretty good idea for what to start with. So, my game doesn't quite have a name yet. I'm still deciding on that, so for now, we're just going to call it my dungeon crawler, because that's primarily what it is. And the topic I wanted to talk about is what I have been kind of studying and playing around with regarding shaders, specifically combining shader effects. So, just to preface first, this isn't going to be a tutorial necessarily. I'm going to talk about um, some of the stuff that I've wanted to do, challenges I encountered, and kind of how I went about uh, working around them and overcame them. And I'll show some code here and there, but I'm not going to be walking through any of it in high detail, and I'm not going to have a step-by-step replication of how I did these things. But I will talk about all of the concepts and try to give an overview of everything, both you know the difficulties I ran into and what I did to solve them and why that worked the way that it did. So shaders. I'm not a shader expert, but I know enough about them, uh, and I definitely wanted to make use of them in my game. Most games will benefit from the use of shaders. They're very versatile and very useful. One of the things that, or I guess two of the things that I wanted to do with shaders, two of the very, most simple but like critical things, were being able to flash colors and being able to change palettes. So color flashing is really useful for stuff like, say, damage feedback, right? A creature gets hit with an attack, flash them like bright red or maybe bright white to show that they were hit and give some visual feedback. It's a very very common technique done in a lot of games. And then palette swapping is another really useful technique. So, I want to be able to swap palettes of certain sprites. Um, maybe I want to do like recolors for different enemies, or I want to have like player customization where they can change the colors of their sprites. Well, I don't want to have different sprites for all the different choices. Having a shader that, switches out colors based off of, some input is really useful, right? So these are two of the things that I want to do, and there's a bunch more, but those are the two really simple examples that I'm going to be using going forward here. All right. So actually doing those isn't very difficult. In fact, it's pretty simple. Like the palette remapping, there's a little bit of thought that goes into it, and there's a couple ways you can go about it. I went for a method that is really quick to prototype, but maybe not the most efficient. Um, but that's not too important. What is important is how to combine them. So shaders in Godot are applied via materials, right? So this knight sprite I have here has a shader material on it, and the shader material I have on is just replicating the effects of modulate. So if I change the modulate color here, let's like make my knight green. If I remove this, it looks the exact same because the shader that I have on is just replicating the process of modulate. So that's, this is a simple way to tint sprites. There are other ways to do it, but this is a pretty easy way to tint them. But the issue is, what if I want to make my guy green, but then I also want to flash him, red because he just got like hit with an attack, right? Well, I can't just switch the material that's on him, right? I, that would lose the modulate. That would make him not green anymore. So I can't just switch it to a different shader material. Well, there are kind of two workarounds to this um, that I've found. So first, let's talk about something that you can't do that seemed to be like the obvious solution to me at first. So multi-pass shaders, right? So we can write shaders in Godot. and you can do your vertex, your fragments, all that good stuff. Um, it's common to want to run something through multiple shaders, though. Well, Godot has multi-pass shaders, but only for certain 3D rendering uh, shaders. There's nothing for 2D. No canvas item multi-pass shaders. So you can't write two separate shaders and then re-render the same sprite, um, you know, with two different passes to do the different effects you want layer on top of each other. So that doesn't work. So there's got to be workarounds, right? Well, there are, and I kind of came across two main workarounds for this. Um, one that is more code based, and one that is done more with different nodes. So the node based approach is probably the much simpler of the two, and it has advantages and things that it can do that the code based approach can't. But the code based one also offers a lot of flexibility and might actually be easier if you're trying to do very complex combinations of shader effects. So I'll go over both, and I'm making use of both, and maybe you'll only use one, but maybe both of them might be useful to you. So let's go over the node-based effect first. So the way to do this with nodes is to use one of the two nodes that makes use of backbuffers in Godot, and there are two different nodes that do that. So there is the BackBufferCopy node, which is pretty obviously named, and then there's the CanvasGroup node, and they work pretty similarly, but have a key difference that I'll go over. Um, but the way that these nodes work is by kind of adding an extra draw step, and what they will do is kind of redirect drawing from going directly to the final output buffer, and instead have them go to a separate buffer and then write from that buffer to the final output buffer, right? So if this viewport frame here is like the final render buffer, um, they will write to some alternate one off to the side, and then whatever drawing you end up making in that buffer then gets slapped onto the main viewport buffer. So that's a very crude summarization, but I hope that it at least gets the idea across. So basically, we have two different drawing steps, and as a result of that, we can do extra work at that second drawing step. And that's how we can, apply multiple shader effects in a pretty simple way. So, I have my knight here. He's tinted green, and I want to then tint him red on top of that. Well, I can place him inside of a canvas group, and that canvas group, again, right? It's got its own separate back buffer. It will draw its children into that back buffer, and then that forms an image. And then when the canvas group itself is drawn, it just reads from the back buffer and draws whatever is there into the final resulting frame buffer. And that draw step we can run another shader on by adding a material to the canvas group, and then now I have this flash color shader on, it's tinting things red. Now I can tint the knight red, and you can see that underneath he's still green, right? So the modulate shader on the knight is still there, and it's making him green. And then the canvas group has a shader on him that is making, tinting him red on top of the color shift to green. So that is one simple way to apply multiple shader effects, is to use canvas groups. So canvas groups and backbuffer copies will work pretty nicely if you only have a handful of effects that you're going to apply at once. Uh, like let's say for my case of doing the palette swapping and the red flash upon being hit, if those are the only two effects you're going to use, this canvas group method is probably the most straightforward way to do that, and it works great for that. It also has some other kind of side effects that are potentially really beneficial. So to best show that, I'm actually going to remove this shader so that I can use the modulate effect, because when you add a material to a canvas group, it overwrites the kind of default built-in shader that it has, and replaces it with your own, custom one that you have defined in your material. So I want to use the built-in one, so I removed my shader. And the example I want to go over here is this line, right? So I have this line here, and let's say I want this to be partially transparent. Um, well, if I go to self-modulate and I set this to be transparent, we can see that we get this intense or more intense color wherever the line overlaps with itself. And the reason that's happening is because during the draw call for this line, it is doing the first rectangle that forms, this chunk of the line segment, and the pixels it's drawing are not, they're partially opaque, or sorry, they're partially transparent. And so when it draws one of those lines and then draws over it a second time, because the pixels are not fully opaque, they blend with the pixels underneath them. And when you draw over previous segments of the line, they blend together to make a stronger color overall. And so you get this effect where the segments of the line are stronger where it overlaps itself. And you may want this, you may not. And if you don't want this, you can use the backbuffers to kind of get away, or to get around this property. And the way you do that is by first drawing it fully opaque. And the reason you do that is so that the pixels are 100% the color that you want the final result to be, aside from the opacity, and they don't blend with anything beneath them. Right, that's the important part. We don't want any blending with colors beneath what we are drawing. Then in the canvas group, right, then we can modulate the canvas group. We can set its transparency, and you see that we get this transparent effect, but there's no blending here because the line has already been drawn to the back buffer. And once it's drawn there, it is now effectively its own, sprite, its own texture, its own image, and all of that data of what's underneath the line segments as you draw over them, that's gone, right? So we first draw the line to the back buffer, and then we take the result of that drawing, which is the fully opaque original line, and then make the whole thing transparent. And so you get rid of that blending effect, and that's useful. So neat stuff that you can do with BackBufferCopy, with CanvasGroup. And the difference between CanvasGroup and BackBufferCopy is pretty simple, thankfully. So CanvasGroup draws all of its children to its back buffer, right? So everything that is a child of the CanvasGroup node gets drawn to the back buffer, and its back buffer size is set to be basically just big enough to contain all of its children. So I have some, let's see, okay, those aren't concern, and so I go to my canvas group and I set a shader on here. See this big rectangle, right? This is the back buffer of the canvas group that I have, right? It's this rectangle that completely contains all of the children, and it's a little bit bigger than it might perfectly need to be, but it's done this way to ensure that everything that is drawn beneath it is going to be saved to the back buffer, so you're not going to lose any pixels. And then, so they draw to this back buffer, and then that is drawn onto, the final frame buffer. But it's only going to draw its children, right? So the back buffer, you can think of it as being, essentially like fully opaque, or sorry, fully transparent at first. And then as pixels are drawn onto it, pixels that are drawn, are opaque. And so when you draw the back buffer out, the completely transparent pixels, they don't change anything underneath them when you draw it. So you end up only drawing the children. Back buffer copy, on the other hand, the way that it works is it reads from the already drawn buffer. You can think of it like that, right? So the already drawn frame buffer. So if I let's say I'm gonna actually move my canvas group over here a little bit so this night overlaps with these Godot icons. So if I was using a canvas group, like I am here, right? We have, let's say we put a tint on this canvas group again. Like, let's add my material again. Let's go get my flash color and let's flash it, red again, right? It only changes the children, right? It doesn't change the Godot icons. If I were to use a backbuffer copy captures anything that was drawn before it, right? So if I did that, and like let's say this was the rectangle I set my backbuffer copy to record, then the parts of the Godot icons that are inside of this rectangle would also be tinted red, right? So that's the difference between the two, and they each have their separate uses. So depending on what your use case would be, you might use CanvasGroup, you might use a backbuffer copy node, right? And so my descriptions of how these work may not be perfectly accurate with how they are written under the hood. Again, I'm not an expert with shaders, and I don't really know that much about how Godot's render pipeline works. But that is, at least from my experimentation, how those two nodes can be utilized to basically apply multiple shader effects. So that was the simple way of doing it via nodes. Now, the drawback of this, obviously, is that you are requiring multiple nodes, and each additional shader effect that you want to apply requires a whole extra node. And if you're only working with a small amount of shader effects, that's not a big deal. But for me, I have run into situations where I might want to apply 3 or 4, potentially even more shader effects, and those shader effects may not necessarily be applied to all of the sprites that make up a creature, right? So for the way my game works, I have a creature sprite. I have separate sprites for its limbs. I have sprites for its items, and I may want to only apply certain shaders to each one of them, right? So like this torch, I may not want it to be tinted red when the player takes damage. So I would need to have the torch sprite not in the canvas group, but the way that I handle my node hierarchy is that items are added as a child of the limb sprite, so that wherever the limb moves, the item moves with it and stays in the hand of the creature. Well, that means that if I want to use canvas groups and apply shaders that way, the item can't be a child of the hand. It has to be outside of this part of the tree. And Godot has nodes that let you work around that. It has remote transform nodes, I think is what it's called, that you can apply to as a child of, let's say, the hand, and then I can connect it to the torch and have the torch somewhere else in the scene tree. And when the remote node gets moved, it will move the torch with it. So there are workarounds to this, but I didn't find it ideal, and it ended up kind of cluttering my scene tree in a way that I wasn't a big fan of. So that was a drawback for me, right? So I can't apply the shaders to only specific children, and for each additional effect that I want to apply, I have to have another node uh, nested, with all the children beneath it, and each additional effect I have to add another canvas group, and make the existing ones children of that new canvas group, and so on and so forth. So that works, but it wasn't ideal for me. So the other way to kind of go about this process um, of kind of faking multi-pass shaders is to kind of dynamically compile shaders on the fly with the effects that you need, right? So if I needed a shader that you know changed the color palette of a sprite and then flashed it with a certain tint color, or tinted it with a certain flash color, I could just write a shader that has both of those effect at once, and I could swap between which ones I needed at which point, right? If I only needed the palette swap, I could start with that palette swap shader and then switch to the combine shader when I need to flash the sprite with the color red, and then switch back when the flash is done. Um, right, so that is a solution. But I didn't want to write, you know, a whole bunch of unique shaders for each individual combination, right? If you only have a small number of shaders, that is probably the best way to do it, right? If you only have, like let's say 3 shaders max, or maybe 4, right? A very small number, then writing different shaders with different combinations is pretty easy to do. Um, but I don't know how many I'm going to need in my final game, and I didn't really want to write different combinations and then have to, update all the different combinations whenever I needed to make changes to, one specific effect. So the other way to do it is, you know, dynamically creating shaders on the fly with the effects you need. And that can be done actually pretty easily because in reality, a shader in Godot it's just a string, right? This file, right? Sure, it's code. Oh, this is the actually explanation for myself on how this all works before I made this video. But this is the actual shader here, and this isn't like pre-compiled. Shaders are not pre-compiled for computers usually because each GPU has different architecture, and so you can't really compile uh, one shader to one GPU and then have the exact same compiled shader work on another GPU. That doesn't really that, that's not really how things work. So usually for PC games, you have to pre-compile shaders at this at when the game first starts running, or live compile them as they come up while you're playing the game. Nowadays, the way people usually do this is to have like a load screen where you quickly render stuff with all the different shaders you want, cache them, and then they're ready to use whenever you need them, right? So that's the most common way to do it, to my understanding. Um, and so these shaders, right? They're live compiled and they're just strings that we send to the GPU effectively, and it compiles them. So we could through code build up the string that we want our shader to be, um, and then just send that off to the GPU. And while that would work just fine, there is actually a slightly simpler way to do it, and that is using shader preprocessor directives. So I tab to VS Code and I pull up this file. So this is my primary creature shader, and the way that it works is this is an actual GD shader, and then I have these little include files, these GD shader include files, and these files are just bits of shader code. They are not shaders themselves. You cannot attach this to a material, but you can include it with a include directive into another file. And so what I have done here is I have these if defs, and if this define is present in the file, then it will include the contents of this include file. And so what I have here is for the 2 effects that I want, I have the palette swap and flash color effect. I can, what I can do is I can take this file, and at the very start of the file, I can just append some text that are defining these 2 terms, right? And so, what that would actually look like is, before this shader type canvas item line, I'd have lines up here that define these terms, and then the rest of the preprocessor, like when I send that string off, right? So that's done in code. I do that in code. In fact, I think here, yeah, this file actually has that, right? So I'm building this string. I have the string builder. Um, in this is C sharp, and what I'm doing is I am taking the text of a existing shader and I am storing it into this or into the string builder, and then at the start of the string builder I am appending these define statements, and so these will come before the like code of the original shader, right? So I'm starting with these defines, and then I'm appending the rest of this text, and that is then sent off, the result is sent off to the GPU to be compiled, right? And so what that means is in code, I can basically cycle through whatever combination of effects I need. I've got an enum, a flag enum here that I use to represent the different effects, and I will create a shader variation for each combination of effects that I want, and I will store them in a dictionary that I can access with the flags that are used to compile the different combinations of the shaders. Then what I do is I have a material on each of the sprites that I want to change the shader effects on, and that material I will swap its shader and as I need to get different effects, right? So here's my actual primary creature material, and here is a simple manager component that just tracks all of them, right? So my creatures are built up of multiple sprites. There's the main body sprite and then all the limb sprites. And so this component here just tracks all of the different materials for each sprite. And whenever I want to make a change to the entire group, I send it to this component, and it then propagates that change to all of the individual materials. And so this is the actual material. And you can see that I have these add effects, remove effects, and set effects functions. And these are the enum flags that I have for the shader effects. And so it just maintains an enum inside of it, a field, and then calling change shader, it reads that field and goes into the shader manager that I showed here and just fetches the specific precompiled shader with the effects that I want. And it also has these structs that contain the data that are set as the uniforms for the shaders. So here I got some uniforms here, some extra uniforms, right? And so this material stores that data so that it can set the uniforms whenever it swaps shaders. So this is a little bit more expensive just because of some catches with how Godot materials work. Um, so the node-based approach with canvas groups and backbuffer copies had drawbacks. Well, so does this live compiling shaders. This also has drawbacks. So neither method is perfect, but maybe one will be more appropriate for your workflow. So the drawbacks of the live compiling shaders with different effects. So resources in Godot are materials, or sorry, materials in Godot are resources, and resources are shared among all nodes that own them, right? And so if I make a change to a material in order to say swap the shader effect on it, all other nodes with the same material are going to have those effects sent to them, right? And they're going to change as well. So if I have like let's say my knight guy, if I have multiple players all using the knight, and one of them wants their knight to be pink, well, if they're all using the same material, it's going to make all of them pink, right? So you have to have separate materials for each knight when you change the shader on them, because when you change the shader on a material, everything that uses that material gets the new shader, right? So that's a drawback. So another drawback is with uniforms. So uniforms are other things that you set on a material. And again, because materials are shared, that means that if you want two different nodes to use the same shader, but with different materials, or sorry, with different uniforms, that means you also need different materials for them, right? So I have, multiple creatures in my game that all are going to use that palette swap shader, right? So I've like this zombie guy here, and I got like little skeleton dudes, right? Um, and they may all end up using the same palette swap shader, But if they're not going to use the exact same palette to swap to, that means that each one of them needs their own distinct material, um, because the uniforms need to be set differently for each one of them, and uniforms are per material. Now, Godot has unique uniforms for shaders, but just like multipass shaders, they're only available for specific 3D shader rendering. Um, they are not available in 2D whatsoever. This is, kind of annoying, kind of frustrating, but it is what it is. There are ways to work around it. So again, the simple way to work around it is just have another material, right? You need to be careful with materials because, again, whenever you change the shader or whenever you change the uniforms on a material, it changes everything that's shared with it. So right now I'm being lazy with this, and every creature that I make gets its own unique material. Now, this means I'm going to have a lot of materials that are going to end up being duplicates, and so I could optimize this, and down the line I will, right? I'll have a set of materials for each creature type, and I'll cycle between them. But right now I'm just doing it on a per creature basis because it's much easier to implement, and I just needed to get it working. Well, so more shape, or sorry, more materials. That's an easy way to do it. Um, there is another kind of hacky way to do this. Um, so the modulate property, we actually looked at that in the beginning, right? So modulate, each node has a modulate property and a self-modulate property, and these are both colors. They are uh, vec4s of floats, so they are 16 bytes, 4 4-byte data types, um, 16 in total. The modulate effect applies to both the current node and all of its children, and the self-modulate applies to just the current node, doesn't apply to its children. And in shaders, if I actually go look at my modulate shader that just replicates it, um, you have this color built in. And when you read from this, it does different things depending on when you read it in the vertex or the fragment shader. If you read it in the fragment shader, then what you get is the color of the sprite that you are drawing multiplied by the node's color. And the node's color is just the modulate and self-modulate colors multiplied together. If you read from the color built in inside of the vertex shader, you only get the node's color, right? You don't get anything from the sprite. Now, the interesting thing about this is that the modulate color is per node. So if I have multiple sprites that all have the shader on them, in fact, I can actually show this as an example. Right, so I have the modulate shader here. If I copy this material and let's say I put it on this torch, right? If I paste it here and I go to visibility and I set the modulate color to like let's I don't know, let's make it not really great tinting options, but make it red, right? Well, and the night's green. This is the same shader material, right? Like if I remove this uh, from here, oh, whoops, that's right. It's still just uses the default modulate if I do that. If I change this to flash color, see it changes both of them, right? So this is the same material, right? And but it's different colors for each of them, right? One's red, one's green still, and that is because the actual like modulate and self-modulate colors are unique for each node. And so that is effectively a unique uniform, right? Because like I showed, you can access that in the vertex uh, function, and you can just save that to a varying and then use it, either in the vertex or in the fragment shader. And so you can have a unique uniform, and so therefore you can use only one material and change, the color across multiple, different instances, all using the same material but with different colors. And you can actually kind of get hacky with this. And if you want to pass other data but not a color, well, so long as it fits in 16 bytes or less, you can just, cast that data, right? You can pack that data into, like, say, a 16 byte struct or however many bytes with just extra padding. And you can cast that to a color and set it to self modulate and then read it inside of your shader and, manipulate it back into its original form. So you can kind of get hacky with this and pass specific data in, like, say, like coordinates or something like that, right? Now, that has a catch as well, and it's that, remember, the color here is the modulate and self modulate colors multiplied together. As far as I am aware, there is no way to just get either of these individually. There might be. Again, I'm not a shader expert, and I'm definitely not a Godot shader expert. But as far as I can tell from the documentation and from experimenting, you can only get the result of these two colors multiplied. And so if the modulate color of either the current node or any of its ancestors is not white, then the self modulate color that you might have set is going to be distorted, right? So if I go to this canvas group and I change its self modulate color to be like teal or whatever, right? It messes with both of these children, right? And so if you are relying on that like hacky technique I just talked about to pass data through self modulate as a unique uniform, you just have to be really careful about how you use the modulate property on other nodes. Now, me personally, I have not used the modulate property on any of my nodes at all, so that works for me, but it may not work for you. But I wanted to point it out. So that's a neat little thing you can do with the modulate property for mocking unique uniforms. But other than that, if you can't get unique uniforms, then what you need to do is have separate materials so that one sprite does not get affected by another. And the lazy way of doing that, which is what I'm doing right now, is just to have a completely new material for every instance that you create. But ideally, you could also have some type of manager that tracks the different materials for say all creatures of one type, and you just switch materials from that central source. And so rather than having a unique material for every single creature instance, you have a unique material for you know just that type of creature, and you have a couple materials and you just cycle them out. So that's one way you could do that. That'd be a little bit more optimized. So that's to kind of wrap things up. This has been a little bit of a long video, but that is kind of been my experience so far with um, multipass or mimicking multipass shaders, combining shader effects in Godot. And so like just a little like example of this, I have this I got my little knight here, and you can see he's like all purple. His hands and his tail are purple as well. I got this zombie here, and my original zombie, right, is brown. But the this one in here, I've got his body tinted with a green hue, and if I walk up and I hit him, he you know he flashes red, but you can see that the red is still tinted green as well. He's still green underneath that red. It doesn't replace the color. And the same goes for my guy. A little hotkey to damage him. You can see he flashes red, but the underneath him it's still purple. So it you know it has worked pretty well for my purpose so far. Um, and I'm going to continue exploring this, and hopefully it will be an adequate solution for my needs down the line as well. And hopefully it will be useful to some some of you out there that have run into the same challenge that I have, where you want to use multiple shader effects, but you don't have a straightforward way of doing it. Well, hopefully one of these two methods ends up being a good solution for you, and you are able to get the desired effect you want. that's going to wrap things up here. You know, apologies that this went on so long. I hope it was at least informative. I didn't have a script for this, um, and I've tried recording this once before, and it was way longer. Oh goodness. But you know, I had fun. I like working on the game. Godot's pretty neat so far. This is my first time ever using Godot, um, so I'm learning a lot, but I still have a lot to learn. Um, and hopefully I can make something pretty cool. Once I get some ideas for stuff I want to talk about in the future, then I will throw together another devlog. And who knows, maybe I'll have a proper name that I have settled on by then, um, so that I don't have to just call it my dungeon crawler. But for now, thanks for watching. I hope that this was either entertaining or informative, um, and I will catch you later.